Good morning, my beautiful learners. That Tshaka, your physical science teacher at Etsa Educational Project Center of Distinctions. So for today, I'm going to do some of revision for the grade 11 learners as well as the grade 12 learners. Remember that electrostatic is part of grade 11 syllabus, but for the grade 12 learners, electrostatic, it is not there in your curricula, but it will be assessed in your June examination, it will be assessed in your trial examination as well as your final examination. So it is very important for you guys to make sure that you revise the electrostatic. Meaning for the grade 11 learners, if you do this topic of electrostatic very well, it shows that when you get to grade 12, you won't be having a problem about this topic of electrostatic. So my beautiful learners, if you continue to do this topic very well, I can promise you that you will be one step out of poverty. So now, my beautiful learners, let us fasten our seatbelt because we are about to fly. Okay, so now question 10, it says that a negative charge of 2 microcoulomb is positioned 10 centimeter from point P as shown below. The first thing that I need to remind you, my beautiful learners, is that whenever we talk about a charge in physical science, we are saying that is measured by what? By coulombs. Charge, the SI unit for charge. The SI unit for charge is what? Is coulomb, which is capital letter C. But sometimes our charge will be given in millicoulombs, they will be given in nanocoulombs, microcoulombs and picocoulombs. So we need to perform the conversion because some other learners are making the mistake of substituting or working with the charge in this form, and then it is not correct. We must make sure that we convert this small symbol that is given in here. So now let me show you. Sometimes our charges may be given in MC, or sometimes our charge may be given in what? In something like UC. And then thirdly, our charge may be given in what? In NC. And then lastly, our charges may be given in PC. So what is this M? This M represent milli what? C. And then that M is equivalent to times 10 to the power of negative 3. Please, my beautiful learners, be aware of that. And then this symbol here is what we call what? Micro C. C represent what? The coulomb. And then what is the value for micro? The value for micro is times 10 to the power of negative 6. I hope you are following, my beautiful learners. And then for N, what is N? N is nano what? C. And then what is the value for nano? Is times 10 to the power of negative 9. And then lastly, my beautiful learners, we have P. P is what? Is pico C. And then what is pico? Pico is equivalent to times 10 to the power of negative 12 C. Please make sure that you are aware of these, my beautiful learners. Make sure that you remember that milli is times 10 to the power of negative 3, and then micro is times 10 to the power of negative 6, nano is times 10 to the power of negative 9, and then pico is times 10 to the power of what? Negative 12. So now a negative charge of 2 microcoulomb is positioned 10 centimeter from point P as shown below, as you can see, my beautiful learners. So the first question that we come across is that define the magnitude of electric field at point P. Define the electric field at a point P in what? In width. So before I explain it, let us define electric field at a point according to the way it appears in our examination guideline. What is electric field at a point? The electrostatic force experienced per unit positive charge placed at that point. You will get your what? Your 2 marks. So guys, let me try to make sense of this, because of some of the learners, they don't understand what is happening here. Here we are having a charge which is negative. Let us remind ourselves of this. This charge is negative. When we are having a negative charge, around the charge we are having what we call the electric field. We are having what we call what? Electric field. Let me write it here. Electric what? Field around a charge. What is electric field? A region in space where an electric charge experience a force. A region in space where an electric charge experiences a force. Let me cancel this one here and then try to do it somewhere here. I'm having a negative charge, meaning around this negative charge I must be having the electric field. The electric field, my beautiful learners, for negative charge, they are always pointing towards what? Towards the charge. So meaning I'll be having the lines that must be attached to our sphere, which is our charge. But this charge, this electric field lines for negative charge, they must be pointing where? Towards what? Towards the charge. That is why sometimes if I have P, or let me just say, my beautiful learners, let me put P here, and then we say that P is our positive test charge. Why are we calling it a positive test charge? Because it can assist us even to understand if whether the charge is negative or the charge is what? Is positive. So now let's check. Here our charge is what? Is negative. Here we are having positive what? Test charge. When I put this charge of P closer to what? To this sphere, what is going to happen? We will witness the force of attraction. Why the force of attraction? This thing is going to be attracted maybe towards this charge. Why? Because the unlike charges attract each other. So that simply tells us that the electric field around this positive charge, around this negative charge, it will pull P towards itself. That is why I'm saying that we can conclude by saying that this charge is negative and then is pulling P towards where? Towards itself. I hope it makes sense. Or let me take another example. I'm having a charge and then we don't know if this charge is positive or what? Or negative. But here I'm having what I call a positive test charge. I know for sure this one is what? Is positive. If I put this charge somewhere here, and then I see this charge moving in this direction. I can conclude by saying that this charge, it has to be positive. Am I right? Yes, because between positive charge and positive charge we have what? A force of what? Of repulsion. So meaning for this one, I'll be having the electric field lines moving where? Moving away from the what? Away from the charge. I hope you get it right, my beautiful learners. Let us recap. For negative charge, the electric field lines, they point towards what? Towards the charge. But for positive charge, the electric field lines, they do what? They point away from the what? From the charge. Because of, in this situation, when we use positive test charge, we saw it that it was attracted towards what? Towards this negative charge. So it shows that the electric field lines of the negative charge, they are pointing towards what? Towards the charge. But for the positive, when we took this P close to P, we saw that when we took this P close to this sphere, we saw that the P was pushed away. So we can conclude by saying that this charge is what? Is positive. And then the direction of the electric field lines, it shows that they must move away from the what? Away from the what? From the charge. So now 10.2, they are saying that draw the electric field line associated with this charge. Which charge? This one. Our charge is what? Is negative. So meaning if our charge is negative, meaning the electric field lines that is associated with this one, it must be this one. And then you'll get your what? Your 2 marks. My beautiful learners, please make sure that when you draw this one, your lines, they don't touch each other. Make sure that you don't draw more lines, because of you will make a mistake of interacting this line maybe with this one. But if you draw it in this situation, you will get 1 mark. And then make sure that your line, they touch the what? The sphere. Because of if you draw the line and then that line that does not touch the sphere, your teacher is going to penalize you. Your teacher is going to penalize you. So please make sure that you practice this one. Please make sure that you practice this one. Are we together, my beautiful learners? Are we together? I'm listening. Are we together, guys? Thank you. Thank you. So now, this is what I want. This question is out of 7. This question is out of 7. A positive charge of 5 microcoulomb is now positioned 15 centimeter from P, as shown in the diagram. Calculate the magnitude of the electric field at P due to both charges. My beautiful learners, let me show you something. What I normally tell my learners when they get here is that they must draw the free body diagram. They must draw the free body what? Diagram. Remember that this P, if they don't say anything about this P, please take this P as what? As positive. It's a positive what? Test charge. Is a positive what? Test charge. If they don't say anything, they give you just P and then they don't give you the magnitude of that, why not just take that P as what? As positive. So the first thing that I need us to do is to draw the free body diagram. The free body diagram that you draw is the free body diagram of the charge that appears in between, because of in this situation we have P, and then in this situation we also have what? P, meaning P, it appears on the x-axis, it also appears in what? On the y-axis. So meaning the free body diagram that I'm drawing here is for that one of what? Of P. So -2 microcoulomb, is it going to attract P or is it going to push P away from itself? Yes, it's obvious that it's going to pull P towards itself, because between the two we have a force of what? Of attraction, or even we are having the electric field in this situation is it has to be to the left. Are we together? Because of the negative charge is going to pull the what? The positive charge of what? Of P. So we say that this one is E, because of we are looking for what? We are looking for electric field. So this one is E. What? Negative 2 microcoulomb on what? On P. This is the electric field of negative 2 microcoulomb on what? On P. Yes. So one other thing, my beautiful learners, we come to this side. This charge is what? Is positive. And then this one is what? Is positive. Positive 5 microcoulomb. Is it going to pull P, or is it going to push it away? Yes, it's going to push it where? Away. Why are we saying that? Because the force that exists between these two charges is a what? Is the force of what? Of repulsion. So the electric field around this P is going to push the P where? Away. Because remember that the electric field around P, they went where? Away from the what? From the charge. So here we are having E what? 5 microcoulomb on what? On P. So now we are done. Now we are done. We are one step closer now. Now let's check. When I was in primary, I was attending a school by the name of Elvis Primary School. And then when I got to secondary, I was attending a beautiful secondary school. That was the name, beautiful. And then our teacher used to give us the method that says K, H, D, M, D, C, M. More especially when we had to do the conversion, because in physical science, most especially in the part of physics, whenever in most cases when we perform the calculations, we are using our distance in what? In meters. So this one is kilometer, meter, centimeter, millimeter. So our teacher used to say, King Henry died miserable death called malaria. King Henry died miserable death called malaria. That was us when we were attending the school. I know that you attended Tshaka Primary School, and then when you go to high school you attended Pakistan Secondary School, and then your teacher maybe said that Khomu ha di mata di kosa marwele. And then that one is not my problem, my kids. That's how you were taught. Hajar. King Henry died miserable death called malaria. That was us. You guys is Khomu ha di mata di kosa marwele. Okay, I'm playing, my beautiful learners. I'm playing. Please don't take it personally. I was just making a joke. It was just a joke. Please take it in that way. So now, my beautiful learners, here is our centimeters. Our distance is given in what? In centimeters. From centimeters to meter, we must divide by what? By 100. Each and every time when you move from right to left, you do what? You divide. But when you move from left to right, you do what? You multiply. So meaning it shows when you are given your distance in millimeter, we are going to divide by what? By 1000. If you are given your distance in what? In centimeter, you must divide by what? By 100. Are we together, guys? Please. So now our distance is 10 centimeter. So from 10 centimeter to meter, obviously we are going to divide by what? By 100. So now my distance here, I'm going to divide it by what? By 100, and then our answer is 0.1 what? Meters. This is the distance that we must have in what? In meters. Even if I divide this one by what? By 100, my distance is equivalent to 0.15 what? Meters. Are we together? Yes. So from now, my beautiful learners, let us check. If I want to get the electric field on this side, which is to the left, I can make use of that equation that says E is equals to K charge all over R squared. Are we together? Yes. Whereby our K is what? It's constant. The value of K is constant, which is 9 times 10 to the power of 9. Multiply by, what is the charge that is given to us? The charge that was given to us in this situation is 2 times 10 to the power of negative 6, because of we have been given what? Micro is times 10 to the power of what? Negative 6. All over the distance between this charge and P is what? It has to be 0.1 what? Squared. And then from here, my beautiful learners, you put everything on the calculator to get the electric field. So it's 9 times 10 to the power of 9, and then we multiply that by 2 times 10 to the power of negative 6, and then we divide that by 0.1 what? Squared. Please press your calculator. What I get on my side here, E is equals to 1,800,000. What I normally do, I don't put the negative signs on my equation. I normally don't put the negative or the positive signs. Why? Because of number one, I've already drawn my what? My free body diagram. The negative and the positive sign, actually they will show you the direction. But what I normally do here, for the fact that I draw my free body diagram, the electric field that is acting in this direction, in between P and this charge, it has to be where? It has to be to the left. But remember that, my beautiful learners, again, before I forgot, electric field is measured in newtons per coulomb. And then what is our direction in this situation? It has to be to the left. Are we together? Thank you. This is the electric field, or let me just say this one is A, just to make things easy. This was electric field A on what? On P. So for now we must go and determine the electric field of what? Of B on what? On P. So here I am. Electric field of B on what? On P is equals to what? K charge all over R squared. What is my K? Remember that K is constant, which is 9 times 10 to the power of 9. And then what is the value for Q? Q is what? Is 5 times 10 to the power of negative 6. All over the distance between the two. The distance between the two is not 15, but it has to be what? 0.15 what? Squared. And then from here, 9 times 10 to the power of 9, we multiply it with 5 times 10 to the power of negative 6, and then we divide with 0.15 what? Squared. And then our answer for this one, it has to be something like 2 million. 2 million what? Newtons per coulomb. But in this situation, where is our direction? Our direction is what? Is upwards. The grade 11 learners, this year when you started with this topic, you were busy with the vectors. When you started with this topic, you were busy with what? With the vectors. So it shows that the first E, it is to the left, and then the second E that we get here is to where? Is to upwards. So obviously that when we determine the electric field at P, we cannot add them. We were going to add the electric field if the electric field that we are having were acting in the same direction, or we were going to subtract them when they were going in where? In different what? Direction, but on the same line. But as you can see here, the other one is moving up, but the other one is moving to the left. So it shows that our E, it lies between the two. So I must draw a line that goes in this direction. This is the E net or E resultant. Remember that when we were resolving the resultant into its component, that's what we used to do when we were employing the method of tail to tail method. So it's still the same here, because of for now we are not looking for this one, we are not looking for this one, but we are calculating on the what? The E net. So this is what we must get. I'm sorry for this line, it must be a straight line. I'm sorry my beautiful learners, it must be a what? A straight line. So now let's check. So obviously in order for me to get the resultant or the E net, I must make use of the formula of what? Of theorem of Pythagoras. So in this situation I'll be saying that E R is equals to square root of E x squared plus E y squared. My beautiful learners, what is our x? Our x is this one, which is what? Which is 1,800,000 what? Thousand, and then I squared plus what is our EY? Our EY in this situation, it must be what? 2 million. So it's 2, 1, 2, 3, 4, 5, 6, and then I put squared. And then from this side I must take everything on my calculator. I have 1,800,000 1,800,000 squared plus 2 million squared, and then my answer is something like 2,690,724,81 what? Newtons per coulomb. So where is our direction? Where is our direction? In this situation I cannot tell, because I cannot say up or I cannot say to the left. It lies between. What I normally do with my kids, I normally tell them to use the Cartesian plane. I normally tell them to use the what? The Cartesian plane, and encourage them to measure the angle from the x-axis. As you can see that here is our Cartesian plane. Here is our Cartesian plane. I normally tell them to measure this angle, to measure the angle that they measure from the what? The x-axis. This side is equivalent to this one, because of we are having a closed what diagram here. I can just say it's a rectangle, so it shows that the opposite sides are what? Are equal, meaning the magnitude of this side is still the same as the magnitude of this side, and then this side is opposite to an angle. this side is opposite to what? To an angle. And then this side here is adjacent to what? To an angle. So what I normally do to my learners, I normally tell them that they must use a tan. The trigonometric ratio there, it must be what? It must be tan theta. So tan theta, as we all know, tan theta is equals to opposite over adjacent. Tan theta is equals to opposite over what? Over adjacent. So now let us see. Tan theta is equals to opposite over adjacent, because for now we are looking for what? We are looking for an angle. And then let me just make theta subject of the formula, and then we have tan second function. What is our opposite side? The opposite side is this one, and then I told you that the magnitude of this side is still the same as this one. The magnitude of opposite side is still the same as what? As this one. And then that one, the value for that one is 2 million. Is 2 million, and then we divide it with what? With 1,800,000 what? 800,000. And then when you put that on our calculator, we have second function of tan what? 2 million, and then divided by 1,800,000, and then our answer for that one, our theta is 48 what? Degree. 48,01 degree. 48,01 degree. And then from there, what I normally tell my learners is that when we measure an angle, let us measure our angle from the positive x-axis. One thing that I know, from here is my positive x. From here to here, our angle is 180. So what I want the angle from the positive x-axis to the resultant. So obviously the angle from here to there, it will be something like 180 degree minus 48,01. So if you say 180 minus 48,01, our answer is something like, our theta is something like 131,99 what? Degree. So my beautiful learners, for now let us write the resultant of what? Of E. So I will say that E resultant at P is equals to, the magnitude is 2,690,724,81, acting at an angle of 131,99 degree from positive x-axis. From positive what? X-axis. So my beautiful learners, please make sure that you practice. I can tell you that you can accumulate more marks in electrostatics. So please go and check other questions, attempt them, and then whenever you come across a question where you don't understand, please consult your teacher, and then your teacher will be there for you. From my side to you, my beautiful learners, that's Tshaka from Etsa. I will see you next time. Thank you.